Welcome to this video on designing integrated and interdisciplinary learning. We will explore a comprehensive framework for holistic education. When learning remains isolated in subject silos, knowledge fragments, and students struggle to connect concepts, relevance disappears, retention suffers, and curiosity fades, stifling natural inquiry. Interdisciplinary learning moves education toward a holistic, real-world approach. When students see how subjects intersect, their learning becomes more relevant and enduring. This approach connects real-world problems and disciplinary knowledge through student curiosity. There are 3 levels of integration. Multidisciplinary subjects share a common theme but remain separate. Interdisciplinary work blends disciplines for a specific problem. Transdisciplinary learning is driven by student questions and real-world problems. The design process uses backward design, starting with desired results. The 5 steps are: identify the big idea, map disciplinary standards, design the performance task, scaffold learning experiences, and build metacognitive reflection. Step 1 is to identify the big idea, a compelling, open-ended question that cannot be answered with just one subject. The question should naturally require multiple disciplines to be unlocked and addressed. Step 2 is to map the disciplinary standards. Determine specific learning outcomes for both the primary discipline, which holds the core content, and the supporting disciplines, which provide analytical tools. Step 3 is to design the culminating performance task. These should be authentic, real-world tasks that prove synthesis, rather than multiple-choice tests. Examples include pitching a sustainable city or a data-driven public health campaign. Step 4 is to scaffold the learning experiences. Sequence lessons logically, ensuring disciplines support each other. A key principle is to teach the analytical tool before the subject that requires it. Step 5 is to build in metacognitive reflection. Include check-ins where students reflect on how using multiple disciplines change their perspective. Prompts can focus on connection, surprise, transfer, or growth. To avoid common pitfalls, beware of the potpourri effect by cutting forced connections. Ensure unequal rigor is addressed by maintaining the academic challenge of every discipline. Finally, combat logistical roadblocks by embedding co-planning time in the master schedule. Comparing the 3 integration levels reveals differences in teacher coordination, student drivers, discipline boundaries, typical settings, and assessment types, moving from separate subjects to fully dissolved boundaries. Interdisciplinary learning provides many benefits for students, including deeper retention, increased critical thinking, and real relevance. It also fosters collaboration, curiosity, and academic rigor, with all standards upheld. Getting started involves 3 phases. Phase 1 is finding partners and agreeing on an essential question. Phase 2 is mapping standards, designing the performance task, and backward designing lessons. Phase 3 involves launch and reflection for refinement. The main takeaway is to break the silos, build the connections, and transform the learning. Start with a compelling question, design backwards from real-world tasks, scaffold disciplines, and always reflect metacognitively.